Question 4, have a go. So, fairly straightforward, I think. To solve a simultaneous equation like this, where you've got some x squares and y squareds, you can't do it by elimination, where you line them up and you add the two equations to take them away. You have to do them by substitution. So start off by rearranging the simpler one to being x equals something or y being something. So I've gone for x equals 2 minus y. So, calling this equation 1, we're now going to substitute this into the second equation, which I'm calling equation 2. So 4y squared minus, well, we replace the x by this equivalent of x, which is 2 minus y, and of course that's being all squared. So this is just a straightforward substitution. X has left the pitch and 2 minus y has come on, equaling 11. Then really we're just number crunching, so we've got to do 2 minus y all squared, so 2 minus y times 2 minus y. That gives us 4 minus 4y plus y squared. Then I've just really sort of expanded this out. Remember, this is effectively a minus 1. So minus 1 times 4, minus 1 times minus 4y, which is plus 4y, and minus 1 times y squared, which is minus y squared. So make sure you understand that that minus is applied to each of these three terms. We then gather our terms, giving us this, and then we've got a quadratic equation to factorize. We're looking for, some people will just do this by sort of trial and error or just by inspection. I've got rather a long-winded way of doing it, which I follow through here in red. So have a go and see if you can follow that. I'm basically just splitting this middle term, factorising the first two terms, factorising the second two terms, and I'm splitting this middle term by considering what two numbers multiply to make 3 times minus 15, which is minus 45, and 4, which is 9 and minus 5. Hence this 4 splitting to 9 and minus 5. Anyway, that gives us y being 5 over 3 and minus 3. Take these y values, substitute them back into either of these, but clearly the linear one's easier, so I've in fact substituted it into this, with x being 2 minus whatever y is, giving us these x values.